Okay, so today we got a big topic, which is climate change, probably the most important topic of the year because no matter what you take next year, no matter what biology you take in the future, no matter what career you go into, we're all affected and will continue to be affected by climate change and the decisions we make surrounding it. So our understanding of it is crucial, especially in this age of misinformation. So hopefully I can clarify some things for you. All right, so before we start talking about climate change, we need to talk about the natural carbon cycle, which follows nicely from our last unit, which was on photosynthesis and respiration. All right, so here we can see carbon. So the carbon cycle involves the cycling of carbon from the atmosphere to living things and then back up to the atmosphere. That's the natural cycle. So the basic gist of the carbon cycle is photosynthesis by plants is going to take carbon out of the air. So use that carbon from carbon dioxide in the air and turn it into sugar, turn it into food, right? So photosynthesis makes the food, and then the tree or the plant is going to use that food to break down that sugar, that carbohydrate, that organic carbon, and release it as they use it in cell respiration to regenerate ATP energy for their cellular work. So when they break down that sugar, it re-releases that CO2 in the atmosphere. So again, absorbing the carbon dioxide to make the sugar, and then releasing that carbon dioxide when you burn that sugar to get energy from that sugar. Well, animals such as ourselves also play a role, of course, because animals eat the plants or they eat the animals that eat the plants. And just like the plants can burn that sugar in cell respiration, the animals that eat the plants can also burn that sugar that the plants made during photosynthesis. And so we see that on here as well. So it can be plants respiring the sugars that they made directly, or it can be animals breaking down that sugar and doing respiration that eat the plants. So that's the short cycle. The longer cycle, like thousands and thousands of years cycle, is when sometimes organisms die before plants or animals, before they have a chance to get eaten. And sometimes those, depending upon how they die, depending on the area of the earth, they can be buried before they get a chance to decompose. And as they get buried and buried and buried over hundreds and thousands of years, the pressure that builds up from that sediment on top of them can change their bodies into fossils as well as fossil fuels. That's why they're called fossil fuels, because they're dead stuff that converted from sugars basically to something kind of like sugars. Just like sugar is a good source of energy, so are these long hydrocarbon chains that we find in oil, natural gas, propane, butane, etc., methane, coal. These are all just different forms depending upon the conditions that they were formed in, different ways that these dead stuff can get turned into fuel. So how do we get these fuels? Well, we learned a while back to drill down for whether it's fracking or oil drilling. Fracking is for natural gas. Drill down and tap into these deep buried sources of fuel, and then of course we use them for fuel, for energy. So we use them in our power plants to burn. We now use them in our cars. We use them to generate electricity, airplanes, other forms of transportation, etc. So it's the major source of our energy in today's modern world. But the problem with that is that it's unbalancing this natural cycle, and so rather than staying trapped as it normally would underground, we're burning it at a very quick rate, drilling for it, burning it, and releasing. When we burn it, we release carbon dioxide that wouldn't ordinarily be there. So that leads to what we call the enhanced greenhouse effect. So the greenhouse effect is a natural process that actually is super essential to life on Earth. So without the greenhouse effect, we wouldn't have life on Earth, but with too much of the greenhouse effect, we have global warming and global climate change. So let's look at the natural greenhouse effect first. So the greenhouse effect is about these greenhouse gases. So these greenhouse gases, such as carbon dioxide and others like methane, are like a blanket that surrounds the Earth. So you can see this orange blanket here. So just like at night, it's nice to have a blanket on most evenings so you can be comfortable and sleep well. It's nice and essential for there to be a blanket, atmospheric blanket surrounding the Earth. This blanket prevents heat from escaping. And so just like a blanket on top of you, if you have a very thin blanket, it's not very warm, and a lot of the heat from your body escapes. If you have a very thick blanket, like we see over here, then it traps a lot of the heat, and not much of that heat escapes, and it's a very warm blanket. So we need a little bit of blanket because the sun's rays are going to warm the Earth, and that warmth is, some of it's going to be released back in space, but if we trap some of it, then we're able to have a nice livable Earth. Otherwise it'd be frozen ice and you wouldn't have life on the planet as we know it. However, as we burn more and more fossil fuels and we increase these greenhouse gases, like when we burn those fossil fuels and release carbon dioxide, it makes a thicker and thicker blanket, trapping more and more heat on the Earth and leading to increased global warming. We can see this very well documented and pretty much, absolutely undisputed in the scientific community. We see this tight correlation between carbon dioxide increasing since the Industrial Revolution and since we've been burning lots and lots of fossil fuels, and as that's increased more recently in the past couple generations. And we see that tightly linked to the temperature increase that we see as well. So notice this is in Celsius, which is what scientists use, but keep in mind that for Fahrenheit, so for Americans, 1 degree is a little over 2 degrees Fahrenheit, so this is more than it looks like. It's also a bigger deal than it looks like, as we'll talk about the effects of just having it up by a couple degrees so far. So what does this mean? Yeah, we see a tight link between carbon dioxide increase and temperature increase, but as I taught you at the beginning of the year, and as hopefully you understand, correlation does not mean causation. So just because you have a tight link between carbon dioxide increase doesn't mean that it causes the temperature. It means that it might cause it. So that was a hypothesis that's been tested and tested and tested and tested and tested and tested thousands of times since then, confirming that it's not just a coincidental correlation, but that it is the carbon dioxide that's thickening the greenhouse effect and warming the Earth. So you probably have heard that this is a controversial topic. Let's talk about how controversial it is. So how controversial do you think it is? Think for a second. What percent of climatologists do you think believe, so climate scientists, what percent do you think believe that global warming is not only real, but caused mostly by humans burning fossil fuels? 97%. This was a number that came out within this last decade, and so hopefully you may have heard that number, and that number is not super surprising to you, but it was when I first started teaching it 5 or 10 years ago, as that number started becoming more familiar in scientific education. So why do we think it's so controversial then? Is 97% of agreement controversial, or would that be considered a consensus? Yeah, it's not controversial at all. Similar to what you'd see, you're never going to see 100% of anything. I mean, you look at evolutionary biology and you're going to see similar numbers so anything approaching 100% is considered absolutely accepted and indisputable. So why do we have this impression that it's controversial when scientifically it's absolutely not controversial? Well, that gets to this question. What percent of Americans believe that global warming is real and caused mostly by humans? And that number is a lot lower. It's only about half actually since then. There's been another study that was updated last year, and it's gone up to, it looks like it's gone up to 60%. So we're making progress, but still way lower and way misunderstood. What about what percent of the 12,000 published studies approximately on climate change confirm human-made global warming? So it's not just that the climate scientists believe it, it's that you actually look at all of those studies and 97% of those studies, so the climate scientists are believing it because that's what their studies are showing them. And then a follow-up study showed that those tiny percent weren't some like geniuses that were ahead of their time. In fact, they were full of errors that when they were statistically corrected for, they actually confirmed the other 97%, putting it at a number that is more like 100%. So you feel free to Google these, search these sources. Absolutely, don't take my word for it. So what are the main effects of global warming? So yeah, who cares? Okay, fine, maybe it's real, but why is such a big deal made of it? Well, it's a very big deal, and we'll talk about some of those now. So global warming is used to be what it's called, but it's much better, more importantly called, or more commonly called, global climate change, because it's not just about warming. That can be misleading. Like, oh, warming, especially when you're in New England, say, oh, great, warming. This is it's too cold most of the year. It's kind of nice, especially if it's only a couple degrees, no big deal. Well, if you think of it that way, it's no big deal, but you're neglecting to think about all the other things that go into climate change. So let's take a look at those. These are things like sea level rise, which we'll look at some of the details and how it affects Boston in the next slide. Increased droughts in some areas and increased flooding in other areas. Not just a little bit, like extreme death-causing droughts and extreme death-causing floods. Seeing this in areas of the US and seeing it, of course, in different areas of the world. How is it possible that we have opposite things? Like, what are you talking about? Climate change is causing droughts and also causing flooding? Choose one, you can't have both. No, that's false. You have to have both. They're both related because of the water cycle. So increased warming leads to increased evaporation. So now you have increased droughts in areas that were prone to high heat and dryness. So they're going to get even drier and hotter in those desert areas. And now what happens to this moisture that's in the air? Well, wind blows it to another area, and then it condenses and precipitates in a different area. So when we have increased rates of evaporation, then we also have increased rates of precipitation. So they go hand in hand. The areas that were already prone to droughts, we're seeing worse droughts. The areas that were already getting that rainfall and or snow, we're seeing worse flooding. We're also seeing increased wildfires as areas get drier. We're seeing this out in California, in Colorado, a lot in the last decade. And it's linked to climate change. We're seeing more intense and more frequent hurricanes with more devastating damage. We are seeing increased rates of extinction of species that are incapable of adapting in time to an increased rate of climate change. And coral bleaching goes in there as well, ruining coral reefs and all of the animals that live and to depend upon that coral reef. So let's talk about climate change. We're not going to have time to talk about all of these. Let's talk about, sea level rise. So when we talk about sea level rise, we're talking mostly about warmer temperatures causing sheets of ice, for example, in Antarctica and in other places. So these sheets of ice melting that have been frozen for hundreds of years or more, melting and then going into the ocean, and then it contributing to the water that's in the ocean and obviously rising the level of that ocean. So that's part of it. The other part of it that a lot of people don't think about is that what do we know about water molecules when they warm? Well, they move faster and they expand. So not only are we having more water from that melting ice, But we're also having warmer water, which expands and rises the sea levels from that factor as well. All right, let's take a look at what this looks like. This is a very helpful website that just came out a few years ago by climatecentral.org, one of the leading organizations looking at climate change. So let's take a look at, whoops, I kind of jumped the gun there, but we're looking at the year 2100, so the end of this century. Here's the current coast. You can type in up here any city or any area you want to see around the world, and use this topographical information as well as factors in all of the current research on sea level rise and predictions from the United Nations panel of Intergovernmental Panel on Climate Change, the IPCC, as well as other studies, international studies as well. All right, so let's look down here. We can see, actually, we can't see that because my hand is in the way. You can see over here the New England Aquarium. So this is Boston, downtown Boston. We can see the North End, Faneuil Hall's over here. We can see TD Garden, Charles River. So let's take a look. This is what it currently looks like. We're all familiar. What about if the future by 2100, if we have sharp cuts to carbon emissions, to fossil fuels converting over to more alternative energy? What does that look like? That looks like some serious underwater conditions, but only right around the edges, so only right around the ocean. So not good, but not too terrible. So looking promising if we can make sharp cuts to carbon emissions. What about if we continue on as usual and we do not make those cuts? Well, then you see a much dire condition, but that by 2100, you can see huge parts of Boston are underwater, including the TD Garden and surrounding streets and streets along the Charles River, including Memorial Drive. All right, going back to... So where are we at? You've probably heard of things like this point of no return, this tipping point. Is this the end of the world as we know it? No, it's not. So let's do a reality check. Most scientists predict that if we allow global temperatures to heat up to this 1.5 to 2 degrees Celsius, so like a few degrees Fahrenheit, which is this Paris Climate Agreement target. So the Paris Climate Agreement, for those of you who don't know, was a 2015 agreement that they've had these climate agreements for over 10 years now. But this one was huge because it was the first time that the US and China, the world's two biggest carbon dioxide emitters from burning fossil fuels, it was the first time that they both agreed to sign on to this treaty. So that was huge. I won't get into all the details, but I highly recommend watching, reading up on it, or just watching a short YouTube video on it. So the Paris Climate Agreement that we signed on to, that Trump has since bailed on, agrees for countries to decrease emissions, carbon dioxide emissions, so that we don't pass this 2 degrees cutoff threshold. There's some disagreement whether it's 1.5 or 2 degrees. Most newer science suggests that it's probably more like 1.5, but at the moment, 2 degrees is all the countries would agree to. It was hard enough to get all countries, it was 200 countries about to sign on to it. The U.S. is now one of the only countries in the world that has not signed on to it. Well, we did sign on, and then Trump pulled us out. So this cutoff of 2 degrees, which the Paris Climate Agreement says will try to work towards and then ratchet up to get closer to 1.5. But this is agreed to be this sort of tipping point. So meaning that up until that point, climate change will get worse, but it will be manageable, more like what we saw in those sea level rise conditions with the cuts, so like some effects, but not catastrophic effects. However, if we pass that about 1.5 or 2 degrees Celsius tipping point, then we're heading for what's known as the hothouse Earth. And that's due to positive feedback loops that I won't get into right now, because I'm already way beyond the time I was planning on, 20 minutes, so I'm going to try to wrap it up in the next few. All right, so 2018 Oxford study calculates that if the world's governments don't initiate a transition to clean energy sources by 2035, so what that means is that the share of renewables, so transitioning from fossil fuels to renewables like solar and wind, if that doesn't start to grow by at least 2% each year, we'll almost certainly pass the point of no return. So this is frightening, but doable. So governments certainly have the technology and they have the wherewithal to make these 2% cuts per year and to continue doing that and avoiding these cutoffs. That's what the Paris Climate Treaty is all about. So if countries can meet those targets, then we can avoid this cutoff. But if the US bails on it and or countries don't, and the US can come back in, so it depends on whether the US rejoins it and on whether other countries can do enough to compensate themselves. How expensive is it to prevent catastrophic climate change? So, why did Trump bail from the Paris Climate Agreement? Well, one of the biggest reasons he cites, and some others who cite for bailing for the Paris Climate Agreement, is that it's too expensive to transition to renewables and that it's not worth it, especially if you don't believe in the science or don't understand the science. So how expensive is it? Well, almost all economists that have studied this question agree that, yes, while it is expensive, it is much cheaper to spend the money on trying to transition and curb carbon emissions than it is to pay for the impact of the resulting climate change. So that's the thing. It's often framed as this number, oh, we can afford to pay that many dollars, that many millions or billions of dollars. Sorry, I don't have the figure in front of me, probably billions. To transition, the losses that are involved in that transition. However, it compares it to zero, and the cost of doing nothing is not zero. The cost of doing nothing is extremely expensive when you talk about the cost of increased damage from sea level rise, the cost of transforming the coasts with increasing flood damage, with increasing sea level rise, with increasing hurricanes, droughts, all these things we talked about first, cost money in the damages, cost millions and millions and actually billions. I'm sorry, I don't have the numbers, but the point is that it'll be cheaper when you look at how much it costs to not do it versus how much it costs to do it. It's actually cheaper when you count those costs in together. If you think that this is just some liberal fantasy or something, the U.S. military, which is generally not associated with a lot of liberal think tanks, the Pentagon and the military has been taking this seriously for over a decade, and they've been planning for this. They recognize that sea level rise is happening. They recognize its effects on their global presence, and they recognize its effects on increased threats around the world that could exacerbate terrorism, and they are doing a lot of work around this. So they take it as a reality, and they're planning around it, and hoping that the effects are mitigated and that we don't see exacerbated terrorism and conflict worldwide over things like decreasing water sources, increased strife around the poverty associated with the disastrous effects of climate change as well. So if climate change is inevitable and the effects are clearly going to be devastating, then some people just kind of throw up their hands and say, well, why should we even bother doing it? It's easy to get kind of fatalistic about it. Like, Jesus, this is super depressing. Oh, well, I guess really there's not much to be done about it. I guess it's just going to happen. Well, that is, I think, not a healthy approach and not a realistic approach. And it's sort of an ignorant approach. And let me say that because the timeline, and I believe this is because of the timeline and the degree of devastation is completely in our hands. So it's sort of like death. And sorry that this is fatalistic, but I'm trying to address this question I normally get in class, and it's an important one, and I want to address it very honestly. And so, yes, climate change is inevitable. Death is inevitable. Human extinction is inevitable. Eventually, but the timeline is to a large degree, under our control. So what it looks like in the next century or two is very much within our control. So rather than throwing up our hands and being like, oh, well, I just found out that we're all going to die someday, so it doesn't really matter how I live. I'm going to do all the drugs I want and, drive drunk and, just have reckless behavior and do things that are unsafe because I'm going to die. Well, no, yes, you're going to die eventually, but the way your life looks is very much dependent to a large degree on the choices, the safe choices that you make throughout your lifetime. And of course, the healthier choices you make, statistically, the longer your lifespan is going to be. So rather than just saying, oh, well, climate change is here, there's nothing we can do about it, we're all going to die, that's not healthy. Don't live your life that way as far as your lifespan and your mortality, and we shouldn't, as a society, live our lives that way as far as climate change. We can do something about it. It's inevitable, but we can stave it off for longer, and hopefully we can avoid that tipping point. And so although things will look worse, they'll look manageably worse. So why has the US not done more about global warming? Well, I'm almost on a half an hour now, so I'm going to really race through this, and this will be our last slide, but I definitely recommend you look more into this. A huge reason the US hasn't done more is that there's been a disinformation campaign by fossil fuel companies who have a lot to lose. Their job is to make a lot of money off of fossil fuel, and why would they want to transition away from fossil fuel when then that's their livelihood? So some fossil fuel companies realize that it's inevitable and they're trying to transition, but many of them are still stuck in this idea of there's still plenty of oil, at least for the foreseeable future, and we need to drill it and we need to keep making money off of it. So it makes financial sense for them to spend a small chunk of their multi-billion-dollar industry to spread disinformation, and that is what they do. That disinformation that the science is uncertain, and it's my job to combat that because the science, as I said in the beginning, is not uncertain. I don't have a vested interest in this. I'm not making any money off of this. I'm just teaching to the standards that are in the curriculum for states around this country and around the world. This is nothing that's not very well established. As I told you in the beginning, feel free to look it up if you're not certain of that. But the biases of the coal companies are certainly have a lot to do with their spending millions of dollars to convince politicians through their funding of their campaigns. And then those politicians are then beholden to them to a large degree. And so the politicians are saying something very different than what the scientists are saying, and this money in politics is a huge reason for it. That being said, there are politicians that definitely understand that the science is clear about this, and they have worked hard to try to pass laws on this, and they have failed many, many times. So during the Obama administration, there was a bill called the Cap and Trade Bill that I won't get into that almost passed, and it was about starting to limit carbon dioxide emissions, but it didn't pass, and that was even in the years that there was a Democratic-controlled Congress. So Obama started doing things once the Congress turned to entirely Republican, and he saw that there was no way he was going to pass these things. He started signing executive orders, doing what he could before he left office to combat carbon emissions, as well as signing up for the Paris Climate Treaty. But Trump has reversed these executive orders and overturned our signing of the climate treaty and pulled us out of it. So Congress is split pretty evenly, not perfectly, but along Democrat-Republican lines when it comes to supporting climate change legislation. So that's something to keep in mind when you're voting. Denial is probably a big part of it. It's easier for us to not think about it, especially when most of us are wealthy enough that it's not really affecting us much right now, and we can continue to be in denial, but it's happening whether we're in denial or not. Lastly, people are reluctant to invest now in combating global warming since the effect seems so far in the future. Highly recommend, if you're interested in learning more about this PBS video of Climate of Doubt that really goes into this question in a lot more details. And I took longer than I wanted, but I hopefully covered a lot of questions that you had, and I can address more questions at another time. Thank you for listening, and take care.